Hi, welcome to the pre-calculus lecture series. And this is the second video for the section 3.6, the rational functions. And since this topic is a little bit long, so we divide this topic into the two videos here. Okay, so from the last video, we started how to sketch the rational functions. So we're going to pick it up from there. So we're going to do one more example, show you how to sketch the rational functions. And then we're going to define the value. We call it the holes and the slant asymptotes here. Okay, so let's go back to our lecture notes here. All right, so as you see, we have we defined how to sketch the how to sketch a rational function. It's kind of like a little kind of the tedious. That's why it took long for us to do. And we have like 5 steps, right? So we kind of want to factor, find the intercept, find the vector, the vertical asymptote, horizontal asymptote. Then we do a little table like this, right? So then we do a little table like this. So we know which, like they go into the legs, it's going to the negative infinity or positive infinities, right? Okay, so let's try to kind of pick it up here and let's do a quick review and let's do one more example before. Okay, so before we do the new things, talk about what is the, so before we talk about what is the holes, those things. Okay, so now let's take a look here. So the first thing here, we said, we want to factors, right? So that's the step number 1 here, factor, like we defined in our note. Okay, so the factors here, so the Rx here we factor, and the x squared minus 4 will be factors x minus 2 and the x plus 2, right? Okay, then the bottom ones here is 2x squared plus 2x. So what do? We set the 2x, x plus 1. All right, so after that, the step number 2, we find the intercept, right? So to find the intercept, the x-intercept. Okay, x-intercept is what? We set a y equal to 0, right? So the x-intercept y equal to 0, so only the top can equal to 0 because the denominator cannot equal to 0. So we know the x minus 2 equal to 0 and the x plus 2 equal to 0, right? So I can get x-intercept is equal to 2 and the negative 2. All right, okay, so now let's try to graph this one. Also, let's kind of put in here is a 2, 4, okay, and 2, 4, let's get a little bit larger here so we can see better, all right. Okay, so let's try to mark our first is a 2 and a negative 2. So this is our what? This is our x-intercept, and I know that it's going to pass in here. Okay, now the next one is here. We want to find the y-intercept, right? So the y-intercept here, the y-intercept, how do we get a y-intercept? We set x equal to 0 here. And as you can see, if you set x equal to 0, what happens here? If you set x equal to 0, then this term is going to become zeros, right? So when this term becomes to 0, then that means the whole thing will become to 0. So we say, okay, this is what? Y-intercept is not exist. Okay, so we don't have a y-intercept here. Okay, so now what is the third one here? Third one is we want to find the vertical asymptote. Okay, so the vertical asymptote is the denominator equal to 0, right? So the denominator here equal to 0. That's the vertical asymptote. So let's try to say here. So that means x equal to 0 and the x plus 1 equal to 0. That means x equal to what? Negative 1, right? Okay, x equal to -1. So let's try to find here. So let's try to mark it. X equal to 0 is here. That's the y-axis. So let's mark it. That this is the vertical asymptote, and x equal to -1 is the vertical asymptotes, right? Okay, so this one is vertical asymptotes here. Okay, that means when I graph it, it's going to do like this. Okay, so this is the vertical asymptote. And now also, then the next thing is here. Okay, so let's take a look at horizontal asymptotes, right? So the horizontal asymptote, that means that when x approach to infinity, and then you see, hey, here is good, they are the same power. So what is the asymptote will be the coefficient in the front, right? So will be y equal to 1/2 here. Okay, so will be the y equal to 1/2. That will be the y asymptotes here. All right, so here let's try to do that. So that will be the y equal to the 1/2. So this is 1. Okay, so this is 1, 2, 3. All right, so the 1/2 is kind of like in here, very kind of small here, right? So 1/2 here. Okay, so now let's do like a little table. So I know how is my things going to be. So here I have my functions here, right? So the first one is a -1. That's looking from the left-hand side. -1, look from the positive side. Then I have what? I have zeros, right? I have another asymptote, look from negative side and from the positive side, see here. So let's go back to these functions here to see the negative, or what we have here. So if from the -1 side, so like if you put, if this is -1s, right? So what do you have here? So you will have like, you put a little bit closer. So this will be the negative, and this is a positive. Then the bottom is negative, and it's negative, right? So in here, you said a negative, positive, negative. So the whole thing here is what? Whole thing here is negative, right? Okay, then the same way is here. Let's take a look if from the -1 from the right-hand side. So what is this one here? This will be positive. Then in here, right? So this is x minus 2 here. So you have a negative -2 is a negative. So here, this is negative. Then this is x plus something a little bit bigger than negative. So we have a positive. So when you put it in here, and then this sign here is what is positive. Okay, let's take a look from the left-hand side of zeros, right? So left-hand side of the 0, 0 minus -2 is negative, 0 plus, so this is a positive. So this is a negative. This is what? This is a positive, right? So negative, positive, negative, positive. So what I have here? So I have here is a positive also. All right, so now the next thing's here. Okay, so the next thing's here, we say here, then this one's here, we see from the right-hand side, so this is still negative, this is a positive, this is a positive, this is a positive. So what do we have for these ones here? We have negatives here, right? So from here, we have negatives here, right? So this is negative. Okay, so now let's try to graph here, right? So we know, okay, from we're going to passing through this intersect, right? So it's going to passing through this intersect. So that's why in here, the first one's here, this one here, because this is my asymptotes, right? So I know my first graph, first leg is going to go something like, oh, that's terrible graph here. All right, so so the first leg is here. Okay, so first leg here is going to go something like that, going down, and this leg going to approach to the asymptote at, approaching to the asymptote at the 1/2 here. All right, and now in here, this one's here, right? So it also going to go through. So it will go through this one here, go through and have the asymptotes here, and have the asymptotes here. Okay, and then the next things here, it will be, so you see here, right? Between the -1 and the 0, between the -1 and the 0, both I'm going to the positive. So I know my graph will be what? Both are going to go to the positive. So that's why my graph is going to be something, like in here. Of course, like exactly, we don't know where that is, but I know this is what is my graph going to go to, right? So they're going to go to the asymptote, go up there. All right, so let's see, so what do we do when we try to graph? And this table is quite important, right? Because this table will tell you, how is your end behavior, so you know how to graph it, okay? Okay, so the next things here we're going to talk about is holes here. So what is holes, right? So we say the rational functions, right? So a while ago we defined, we said the rational function x here is two polynomials, so the px and the qx. So at the beginning when we defined it, we said, hey, there is no common terms, right? So, but how about the px and the qx, they have the common factor, okay? And those common factor, and which will cause, which make the denominator equal to 0. I know the loss of factor make the denominator equal to 0, so it's not defined in the, in the domains, right? But we can cancel out. So we can cancel out the common term and the common factor, and leave, what do we call this? The holes here. All right, so this is not a hole, it's a hole, right? So it's okay, so let's leave a hole here. Okay, that is what we have. We define is the definition of the hole, and we're going to do some examples here. Then in here, the next thing here is similar. So what is the slant asymptotes here? The slant asymptote is another situation is Rx equal to the Px Qx, right? So we said the degrees of the Px is greater than the degrees of the Qx here, okay? Then you can use the long divisions, and you can rewrite this Rx is equal to something like ax plus b plus, then we have, like, we talk about the remainder and the qx, right? So instead of the asymptote, yes, we have a vertical and the horizontal, right? So right now we have this, we call it a slant, because it's a slant, because it's lines, right? So that means that we're going to have line as the asymptote. That's what we call is the what? That's what we call is the slant asymptotes here. Okay, so now let's take a look at what is this one here. We said graph the following functions here. as always, right, we said the first step, what do we do here? We say, hey, first step is here. We are going to factors, right? So the s of x here, so here this is x minus 3. Oh, x squared, so you can take the x out, and then this is x minus 3. Oh boy, so like x minus 3 and x minus 3, and those are the common factor. And those is when the x equal to 3, right? So when the x equal to 3, I know you cannot make it. So this one, if you cancel out, is 1 over x. So we know we have a whole at x equal to 3. Okay, so now let's take a look. So this one, this is x equal to the 1 over x, right? Okay, let's try to do the things here. So this is 1, 2, 3, 4. This is 1, 2, 3, 4. 1, 2, 3, 4. Right? So we know this is a parent function. So I know what is the basic looks like. So at 1, 1 going to be here, and 1/2 going to be here, and the 2 will be here, right? So this will be your parent functions here. That's what we have. Here's 1, 1 here, 2 here, and 1/2 is here, right? So this will be here, right? So the graph is supposed to look here. But in here we say, hey, because x minus 3, we cancel out. So we have a what? We have a holes at x equal to 3. All right, so what does that mean? That means when x equal to 3, the s of x equal to what? 1/3, right? But 1/3 is a holes here. So let's see here, 1/3. So that means for this graph, instead of this continuous, I have a hole, I have empties here. Did you see that? Okay, so that will be, that's what we called is the holes here. So basically, I hope that I don't erase it too much here. Oh, okay, so here, that means when the x equal to 3, instead of have a line, you have a hole here. And then your remaining graph will be, oh, where is my hole? Disappeared. Okay, so hole is here, right? And then the remaining of the, so the remaining of the graph, oh, it's disappeared again. I don't know why. Okay, so here, don't like my holes here, right? So here, okay, so hope it's not disappear. Okay, it's good. So that's what is your graph going to look like. So it's look like a parent function, but at x equal to 3, I'm going to have a hole here. That's what I mean, the holes here, all right? Let's take a look at these functions again. This is the one, x cubed minus 2x squared. Okay, so that's step number 1, like always, with factors, right? So this is the tx, so let's factor it. So this is x minus 2. So you take x squared out, right? So then you will have x what? Minus 2. Oh, wow. So the x minus 2 and the x minus 2, they are the common terms. And what can I do? I can cancel that. So what this one will give me? This will give me x squares, right? So, but I cancel out. So what I have here, we have a whole. So we have a whole, you know, we have a, so we have a whole at where? So we have a whole at x equal to 2, right? Okay, now your functions, after I cancel, so your function become the parent functions here. All right, so let's take a look. So what is this function looks like? So we still do this is 1, 2, 3, 4. 1, 2, 3, 4. This is 1, 2, 3, 4. And this is 1, 2, 3, 4. So for now, you should be very good at the graphing the parent functions, right? So let's see here. So x equal to 0, I have the first point, 1, 1, 2, 4, 1, 2, 3, 4, and the 3, 9 is way up here. Then negative 1 is 1, negative 2 is what? It's 4, negative 3 is up here, right? Okay, so now you do here, but then you notice, right? So you notice here, you say, hey, I have a hole at x equal to 2. That means that at the x equal to 2, I need to graph a hole. So let's see here, what does 2 mean? So that means 2 to the square equal to 4, right? So that means at this point, right, instead of it's a solid point here, what you have here, this pointer is a hole, right? So 2, 1, 2, 3, 4, 4 here is a hole. Instead of it's the point. Now I can connect my point here. So this is a, how do I connect my point, right? So this is a hole. Okay, so this is a parabola, and your left-hand side is okay, it's a, you know, so but the right-hand side, you got a hole there. That's what we mean, the holes here, all right? Okay, so now let's take a look. Okay, so now let's take a look at the next ones here, the slant asymptotes here, right? So let's take a look at the slant asymptote and see how do we do the slant asymptotes here. Okay, so the slant asymptote is here, right? Okay, so let's try. Okay, so for these ones here, as you can see, you know, the top of the, you know, the top of the powers here is bigger than the, so this is 2, this is 1, right? So it's bigger than the bottom of the powers, right? So that's why we need to find the slant asymptote. So first, still, let's try to do the step number 1, factor, because we do need a factor to go to get the asymptote those things. So this is x minus 5, x plus 1, and this is x minus 3. So I don't have any common term to cancel. When I don't have any common term to cancel, then I know I don't have holes here. Okay, so now the next step is here, the x-intercept. X-intercept is y equal to 0, right? So the y equal to 0, that means x minus 5 equal to 0. So I'm getting the x equal to 5. And I also have x plus 1 equal to 0. I'm going to get the x equal to the negative 1. That's the x-intercept, y equal to 0. Then the y-intercept is when x equal to 0. So when x equal to 0 is 0 minus 0 minus 5, 0. So what I have here, y is negative 5 over negative 3. So it's 5/3, right? All right, so now let's try to plot my point here. X equal to 0 is 5. Okay, let's try to make it a mark. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. All right. So I make the mark here. So my x-intercept going to passing 5. So going to passing at this point, right? I'm going to passing at this point, and also I'm going to passing at this point, right? Then my y-intercept is 2/3, so somewhere it's going to be in here, correct? Okay, so now this is my x-intercept. Now we are going to find the asymptote. So the vertical asymptote is the denominator equal to 0. So it's x minus 3 equal to 0. So x equal to 3. Okay, so this is my vertical asymptotes here. Okay, x equal to 3, so it's in here, x equal to 3. So, okay, and then now you don't have the horizontal asymptote, because if you find the horizontal asymptote is when x approach to infinity, and so here, this is the one, so that I know the y going to, so y going to go to the infinity, so I don't have no horizontal asymptote. But because of the degrees here is higher, so now let's try to do the long divisions, right? So this is x squared minus 4x minus 5, x minus 3. I assume you all know how to do the long divisions. So I have this is x minus 1 and minus 8, x minus 3, right? Okay, so from here to here is a long division. The reason why I want to do the long divisions because then this is this x minus 1. What is this? This is my what? So the y equal to the x minus 1. This is what I call is a slant asymptote. Okay, so let's take a look. This is what I call the slant asymptote here. Okay, so let's try to graph it, right? So the y, x equal to 1, what is y equal to? Y equal to 0, right? So this asymptote going to pass here. X equal to 2, y going to pass is equal to 1. X equal to 5, what is y going to be? 4, right? Let's take a look. X equal to 0, y equal to negative 1. X equal to negative 2, y equal to negative 1, y equal to negative 2, x equal to negative 2, y equal to negative what? Negative 3. All right, so you graph this one, so this one, okay, so this, the blue line, this is my slant, right? So be careful, this is what we call this, the slant asymptote. That means my graph is going to go like this, right? All right, so now in here, now let's do that little table again to help us to see, okay? So now, because I only have one vertical asymptote, so I do the 3 to the left and the 3 to the right. Okay, so when the 3, if they go to the, from the left-hand side, 3s, right? So this will be negative, positive, and negative, right? So that will be what? That's what's that mean? That means this number going to go to positives, right? Now, if you have the 3, okay, so if you have the 3 from the right-hand side, and what you're going to do, so the 3 from the right-hand side, you put it here, this is a negative, this is a positive, this is a positive. And what I have negatives, right? So I have a negative, okay? And then my other end going to be, because this is my slant, right? So in here, and I'm also going to passing through my intercept, right? So let me extend this line a little bit, right? So here, something. So now I know my graph going to look like this, right? So here, because I'm going down here, so this leg going to go like that. Approach to here. And then this leg, I need to be very careful. This is very difficult to graph here, right? So here, so let's see here. But this leg passing that, so they're going to asymptote. This is slant asymptote. So it's kind of like go like this, and this one going to go kind of go like this to the slant asymptote. Okay. Then, like if I approach from the left-hand side, so it will go in positive infinity. So I need to pass in these 2 points also, right? So I'm going to have something go like this. All right. So it's kind of like this end going to go to this slant, this end going to this vertical. So of course my graph is not too it's kind of because of scale and it's not, but you can understand, right? So because I know this end is going to be positive, so that means I know this end is going to approach to this slant asymptotes here. Okay, that's it. That is for the section 3.6. It's kind of a big section, and it's kind of like the sections you need to be very careful. So the key things to remember is how to find the vertical asymptote, find the horizontal asymptote, how to find the slant asymptote, and what is the holes, right? Then after that, how to combine all this information and try to graph. Okay, that's it. And we finished the section 3.6. And I hope those graphs can help you get a better understanding what is the rational function looks like. All right, so remember the key things: horizontal asymptote, vertical asymptote, slant asymptote, and the holes. Okay, sounds good. And looking forward to talk to you in our next sections here. Okay, bye.